And now going to part B. Part B says, find the equation of the tangent and the normal to the curve y equals to x cubed plus 5x squared minus 3x plus 2 at a point 1 and 0. So let us begin by getting the equation of the tangent. To find the equation of the tangent, we need the gradient of the tangent. The gradient of the tangent at the point of tangency is the same as the gradient of the curve at that point. So let us get the gradient of the curve. For us to get the gradient of the curve, we need the gradient function. So we differentiate the given function of the curve. Therefore, dy dx becomes 3x squared plus 10x minus 3. This is the gradient function of the curve. This is the function that gives us the gradient of the curve at any point. What about now at the point of tangency? What is the gradient of the curve? So dy dx becomes dy dx at the point of tangency 1 and 0 becomes, this is x, this is y. We substitute for x in the expression for the gradient function. So we shall have 3 times 1 squared plus 10 times 1 minus 3. This is 13 minus 3, it is 10. So the gradient of the curve at the point of tangency is 10. And we know that at the point of tangency, the gradient of the curve is the same as the gradient of the tangent. Therefore, gradient of the tangent is also 10. Now, if we know the gradient of the tangent and we know the point through which the tangent passes, we can find the equation of the tangent. Remember, this point of tangency is for all, that is the curve, the tangent and the normal. So you can use it on the curve, use it on the tangent, and we use it on the normal. So that point is 1 and 0. So this is x, this is y. This is our gradient n. So the equation of tangent of the tangent is a line becomes y equals to mx plus c. This is n, x and y are here. So y is 0, m is 10, x is 1 plus c. And know that c is the y-intercept. So from here, when we make c the subject, it gives us negative 10. C gives us negative 10. So after getting c, then we substitute here for m and c. So the equation of the tangent becomes y equals to m is 10. So we shall have 10x minus 10. And that is the answer. After getting the equation of the tangent, we need the equation of the normal. The question as asked for both. So equation of the normal, line. What do you know about the normal and the tangent? You know that the normal is perpendicular to the tangent, and the normal is perpendicular to the tangent. What is the implication of that? It means that they are perpendicular lines, and we know that if you have the gradients of perpendicular lines, it means that the product of the gradient of the first line and the gradient of the second line equals to negative 1. So let me call the gradient of the tangent m1. I substitute m1 there, so that I have 10 m2 equals to negative 1. Therefore m2 is negative 1 out of 10. So m2 is the gradient of the normal. If you have the gradient of the normal and you have the point through which the normal passes, then you can find the equation of the normal. This point is for all, that is the curve, the normal, and the tangent. So when you have the point 1 and 0, and then we have the gradient negative 1 out of 10, then we can find the equation of the normal. Because a normal is a line given by y equals mx plus c. Now let us get c where c is the y-intercept. So we substitute, this is x, this is y. 0 equals to m is the negative 1 out of 10 times 1 plus c. That means c equals to 1 out of 10 when you make c the subject. After getting c, you can substitute for m and c only. Therefore, the equation of the normal becomes y equals to negative 1 out of 10 x plus c, which is also 1 out of 10. And this is the solution to